I'm now going to show you some of these calculations that you're going to need to be able to do. So please be sure you have a calculator ready to go, and you could kind of walk through each one of these, and please pause the video when you get a chance. So we're going to use the first equation, which is C is equal to lambda times nu, lambda times frequency, wavelength times frequency, however you remember it. And please note I will give you this constant of 3 times 10 to the 8th. So I'm going to do a number of problems for you so you can kind of see where these all come from, and you get the practice. If this is simple to you, you could kind of just skip through this and go to the practice. So 4 times 10 to the negative 6 meters, what is the frequency? Well, the nice thing about these calculations is you are always going to be using the speed of light is equal to frequency times wavelength. So you will always be dividing into the speed of light. No matter if I give you wavelength or I give you frequency, you're always going to be doing the exact same thing. So you're going to be taking 3 times 10 to the 8th and dividing it by whatever the wavelength of the frequency happens to be. So this is 4 times 10 to the negative 6. So really, the only thing you need to be aware of is with your calculators is how to do the calculation using this function on your calculator called the double E function. So if you've never used it before, I suggest you take out your calculator and try it with me. So I'm going to type it in using the EE function. What the EE function does is essentially does the 10 to the whatever it happens to be. So I'm going to type this one in. I'm going to take 3 times, so I'm going to do second function E, and then the E should show up on your screen. So again, if the EE function is above it, you have to hit the second function key in order to hit it. So then I'm going to type in 8. So what that's saying is 3 times 10 to the 8th, and I'm going to hit the division key. Okay, and then I'm going to take my number, my wavelength, excuse me, 4, again, I'm going to hit the second function key, so this blue key, and then the second function is going to come up on the screen, and I'm going to hit the EE function, and the E is going to come up there, and this is negative 6. I'm going to type in negative 6, and I'm going to hit the equal sign, and it's going to spit out my answer, which is 7.5 times 10 to the 13th hertz, 1 over seconds. You could also write that in as well. I will take any kind of unit as long as it's the correct unit for that. So again, using your calculators, you're going to type in 3, second function E, 8, hit the division key, and then take 4, second function E, negative 6, and I'm going to get 7.5 times 10 to the 13th as my answer. Okay. And I strongly urge you to use that double E function. Otherwise, you have to put things in parentheses if you use the 10 caret thing on your calculator, and it just becomes a little bit more of a pain in the butt. So then the next problem you have on your sheet is frequency is 2.6 times 10 to the 15th. What is the wavelength? Again, you are always dividing into the speed of light, no matter what variable I give you, either the frequency or the wavelength. So that's going to be 3 times the 8th. Divided by 2.6 times 10 to the 15th. Again, let me show you that on the calculator. Okay. So you're going to type in 3, second function E, 8, hit the division key. Okay. And then our number here is 2.6, second function E, 15. Okay, so that's what your screen should look like when you are doing the calculation. And just hit the equal sign. And then you might get a number like this. Well, this is in normal notation. So there is a button on your calculator called the scientific SCI. So I get the second function key and hit that, and then change it to scientific notation, and it will do it for me. So this comes out to be 1.15 times 10 to the negative 7th, which again, rounding it to 2 digits, I rounded it to 1.2 times 10 to the negative 7th. And again, I do not care how many digits you write down in this course. It's more of just trying to get the practice. Now, once we have the meters, okay, once we have meters, because this is wavelength, I want you to also convert to nanometers, okay? So I'm going to do this as an example. So I'm going to change this from meters to nanometers. Well, I know that every meter is 1 times 10 to the 9th nanometers is going to be how I convert this. So in your calculators, what you could do is you could type in 1.2, second function E, this is negative 7, and I'm going to multiply it by it. So this is called a dimensional analysis way of doing this type of problem. So I'm going to multiply it by 1. So I hit multiplication. 1, second function e, 9. Okay, so that's going to be the power of 10. And when I put that in my calculator, I get 1.2 times 10 to the 2. Again, if I want to change my notation to normal notation, it comes out to be 120, which is my answer. Okay, so you will have to convert things to nanometers when you're doing these calculations. So try the next one. Okay, try the next one. So wavelength, I have 612 nanometers. What is going to be the frequency? So before you could plug it into any equation, you have to change the nanometers to meters. It has to be done. So see if you could try that. Pause the video and then pick it up. So as you could see, I have 10 to the 9th nanometers. So that means I'm going to divide it. Okay. So I'm going to take 612, okay, division, and I'm going to take 1 second function E9 and divide that into it. Again, you could change your notation to scientific notation, and it comes out to be 6.12 times 10 to the -7 meters. Okay, so that's got to be the first thing that you do when you do anything with nanometers, is it has to be in meters before you do any calculation I'm about to teach you. Once that's done, it's the same. Okay, so 3 times 10 to the 8th divided by your meters here, and I get my hertz. So that is going to be, again, another step in the calculations that I'm going to have you do. So another calculation we're going to do in here is going to be with this equation. Energy is equal to this H times nu. Okay, so this is going to be another equation that you're going to need to have. So this is saying something about the energy of the light is equal to H times nu. Okay, well, H is something called Planck's constant. Okay, and that is in your notes, I believe. I believe that's in your notes. So let's go to that page for a second. Let's go to that page. That's a better page. Okay, so energy is equal to Planck's constant times frequency. Again, you could have energy is equal to Planck's constant times F. Doesn't matter to me. So there was a scientist called Planck who figured out that there was some kind of relationship between the energy of the light and the frequency of the light. So there was some relationship, and it had a constant. So H is called Planck's constant, and this number will always be given to you. So you will have to memorize the equation, okay, but I will give you the constant. And this is frequency. Again, it's going to be F or nu, either way you want to use it. Is going to be fine. It's going to be 1/seconds. So it's always going to be the same calculation in the fact of if I give you energy and how to find frequency, if I give you frequency, how to find energy. So I will walk you through a couple examples of those before we get to the harder problem.